What is the arithmetic mean? Arithmetic mean. Arithmetic mean. Arithmetic mean. So, arithmetic mean is a what? What is the definition of this one? If we try to define arithmetic mean, arithmetic mean is ratio of sum of observation and number of observation What is the meaning of this one? Arithmetic mean is a ratio of a sum of observation and number of observation. So mathematically, how we define this one? Mathematically, if x1, x2 up to xn be the number of observation. If x1, x2, xn be the observation, value of observation, with the observation, then if x1, x2, xn be the observation or means values of the data, then arithmetic mean and standard notation of this one is what? X bar equal what? Sum of observations in sum of the data x1 plus x2 up to what? Xn divided by number of observation. Number of observation is what? N. So this one is what? This one is arithmetic mean. So if data is given in a form of a frequency, means x, now arithmetic mean, if data is given, is in form of frequency distribution. If data is in form of xi fi means in term of a frequency distribution. So then arithmetic mean is what? Arithmetic mean, if we write this one is arithmetic mean, this one, arithmetic mean x bar equal 1 upon n summation of fi xi. Here I ranges from what? I ranges from 1 to n. So here this one summation also ranges from I equal 1 to n. Where capital N is what? Capital N equal summation of fi, sum of all the frequencies. I equal 1 to n. So if this one is given in the form of a frequency, if this one is given in a form of a class interval, if data is given in a form of a class interval, data in the form of a class interval, then how we define the x? X equal what? X equal xi with the mid value of a class interval. So if a class interval is given, then we find the mid values of a class interval x1, x2, x3 up to xn. Then according to this way, means arithmetic mean equal 1 upon n summation of fi xi equal what? Arithmetic mean. Sometimes frequency means the value of x is too much large. then the calculation become very tedious and time consuming. In this case, we use the what? We use the one another means if we write here, or we find the, if we write here, then how we find the, means if the value of x is too much large, and then what will happen? As we say that this one take too much time for the calculation of fi xi. So in this case, we assume that di means one another variable, this one is xi minus a with any constant, here a with any constant. Then what is the value of arithmetic mean? Arithmetic mean become what? Arithmetic mean, here we try to define arithmetic mean, x bar equal what? X bar equal, how we find the arithmetic mean of this one? So here we multiply by the frequencies corresponding and take the summation. Then summation of multiplied by the frequency fi, take the summation fi di equal summation here in a left hand side as well as right hand side. Then right hand side becomes summation of fi xi minus a. Suppose we here also divide both sides by the 1 upon n. So because there is no any change, if we multiply 1 by n on the left hand side and 1 by n on the right hand side. So if we simplify this one, then 1 upon n summation of fi di equal 1 upon n summation of fi xi minus, if you open this bracket and operate the summation, minus 1 upon n summation of fi into a. A is the what? Constant. So a become outside. What is the value of summation of fi? Summation of fi is at n. So capital N cancel out. So what is the value for this one? This one become a. So and what is the value for this one? This one is the x bar. So this one is the x bar, and this one minus summation of fi, a with the constant. So this one become outside from the summation. So inside 1 upon n summation of fi become n. So this one become what? X bar minus a equal what? 1 upon n summation of fi di. So what is the value for mean? X bar equal what? A plus, here this one goes on the left hand side, then this become a plus 1 upon n summation of fi di. This one is another formula. Means this one is another formula. Like this one is what? This one is also arithmetic mean. This one is arithmetic mean. Now, third one is the what? If here we write arithmetic mean. Third one is the what? Sometime by using this one di equal xi minus a, the data is not reduced, means as much as required. Means also if we use this one, the calculation may take, means maybe the time consuming. So what will happen here? In this case, we also divided by the what? Divided by the length of a class interval. Then if we divided by the length of a class interval, then what is the arithmetic mean? So here we write what is the arithmetic mean. So if di equal what? Arithmetic mean, if we write here arithmetic mean, then di equal what? Here we write di equal xi minus a upon h. H is what? H is the length of a class interval. H is the length of a class interval. Length of class interval. Length of a class interval. So now again, like in this way, like here we multiplied by the fi and take the summation and multiplied by the 1 upon n. So this one become what? Here we write h into di equal what? xi minus a, then multiplied by the frequency, then this become h into fi di equal fi xi minus a. Take the summation on both sides, then and multiplied by the 1 upon n, then 1 upon n summation h fi di equal 1 upon n summation fi xi minus a. And if we simplify this one, then this become what? This become h with a constant, so this become outside. So what is the value? H time 1 upon n summation of fi di equal what? Equal 1 upon n summation of fi xi minus a 1 upon n summation of fi. So if we simplify this one, then this one become what? This one become x bar. So x bar equal what? X bar equal, and 1 upon n summation of fi become what? Again summation of fi become capital N, capital N, capital N, cancel out. So this one become a plus h time of 1 upon capital N summation of fi di. So this one is another form of another form of formula. We use what? Di equal xi minus a upon h. So these are the three form of a formula. Means if for xi fi, then 1 upon capital N summation of fi xi, and if di equal xi minus a, then arithmetic mean is a equal a plus 1 upon n summation of fi di, and if di equal xi minus a upon h, then x bar equal a plus h time of 1 upon n summation of fi di. So these are the a different form of arithmetic mean. Now we discuss about properties of arithmetic mean. Properties of arithmetic mean, then we solve some numerical problem based on arithmetic mean. So now properties of arithmetic mean. Properties of arithmetic mean. Properties of arithmetic mean. Arithmetic mean. Arithmetic mean. Properties of arithmetic mean. First properties, the sum of deviation from mean. Sum of deviation from mean is what? So first property is a sum of deviation from arithmetic mean is zero. What is the meaning of this one? If we find arithmetic mean and find deviation from the data, then what is the sum of these deviations? Sum of these deviation equal 0. How we prove this one? Sum of a deviation from arithmetic mean means suppose arithmetic mean is a what? Arithmetic mean is a what? X bar. Arithmetic mean is a x bar. So deviation from arithmetic mean is a what? Suppose x is a data. So deviation is a what? X minus x bar. So xi minus x bar. This one is a what? Deviation. And we denote this one by the di. Di equal what? Xi minus x bar. Di equal xi minus x bar. Sum of a deviation means the sum of this one di equal what? Summation of xi minus summation of x bar. If there is n data, then what is the value for this one? Summation of xi equal what? We know that x bar equal summation of xi upon n. So what is the value for summation of xi? summation of xi equal n into x bar. So this one equal to n x bar, and summation of x bar, if we add any constant n time, then this become what? Nx bar. So this one become what? 0. So this here, this one is a sum of a deviation from arithmetic mean is a 0. You may also also prove this one, means if data is given in term of a frequency. So here, if xi of I is a given, xi alternate proof means alternate proof here. If data is given in term of this one, xi of I, then we find the deviation from the algebraic sum. So sum of algebraic sum of a deviation from arithmetic mean is a 0. So here what we denote? Here we write what? Algebraic sum. Algebraic sum. Algebraic sum. So here then arithmetic mean is a what? Arithmetic mean is a summation of 1 upon n, summation of fi xi, and this one denoted by the x bar. Now what is the di? Di equal fi xi minus x bar. Fi xi minus x bar. So summation of di equal summation of fi xi minus summation of fi x bar. And we know that what is the value of a summation of fi xi? This one become what? This one become n x bar, and summation of fi is what? Capital N x bar. This one become what? This one become 0. So in this way also we able to prove, means if data is given in form of a frequency distribution, means corresponding to x, what is the frequency? Frequency is a f. So now second property, if we prove the second property is a algebraic sum of square of a deviation is minimum. Algebraic sum of a square of a deviation from arithmetic mean, if we write here arithmetic mean. Algebraic sum of a square of a deviation from arithmetic mean is minimum. So how we prove this one? So you may prove this one like this way, means like this one. Di equal, if di equal what? Xi minus x bar. So algebraic sum of a square of a deviation. So di square equal what? Xi minus x bar whole square. So algebraic sum means fi di whole square summation of this one equal what? Summation of fi xi minus x bar whole square. So how we prove this one? Here we assume that x bar equal what? X bar equal a. So here we write what? X bar equal a. Then we saw that the value for this one, suppose this one is a z, algebraic sum of a square of a deviation, we saw that this function give the minimum value if capital A equal what? Capital A equal x bar, then we able to prove this one. So what is the necessary condition for the maxima and minima? Necessary condition for maxima oblique minima is a what? Del z upon del A equal to what? Say del z upon del A equal to 0. So if we differentiate partially with respect to a. So here del z upon del a, this one is a function of only a, so not here we write del z upon del a, here we write dz upon dA, dz upon dA, dz upon dA, dz upon dA equal what? 2 times of a summation of a fi xi minus a. This one equal what? This one equals 0. This one equals 0. So if we simplify this one, then what is the value? This one becomes summation of a fi xi equal summation of a fi into a. So the value for a becomes summation of a fi xi divided by summation of a fi, and this one nothing is 1 upon capital N summation of a fi xi. And what is the value for this one? The value for this one is the x bar. So with the help of a necessary condition, a equal what? A equal x bar. This one gives the minimum value. If what will happen? If d2z upon dA square is a what? Is a greater than 0. So what is the value for d2z upon dA square? If we differentiate one time more this function, then d2z upon dA square equal what? This one gives the 2 times of a summation of a fi. Summation of a fi. And summation of a fi is a what? This one is a capital N, 2 times of a capital N, and number of data, number of observation is always a positive. So n is always greater than 0. So this one is a greater than 0. So this difference, this value z equals summation of a fi di square equals summation of a fi xi minus a bar whole square. This one means square of algebraic sum of a square of a deviation from arithmetic mean always is what? Always give the minimum value. So this one is a second property. Third property is a what? Third property is a, we talk about the third property, here we write the third property. Third property means if there is a n series, means a k series, not a, there is a series having a k component. So there is a k component series, then composite arithmetic mean of the series k component series means this one is a x1, x2 up to what? xn1. This one is the first series. Similarly, second series is what? Here we write I. Not I, here we write what? Not in this form. If we write what? If we write in this form. There is a k component series. First series is a what? x1, x2 up to xn1. Second series is a 1, 1, 1, 2 and 1 and 1. Second series is a x21, x22 up to x2 and 2. And similarly, there is a xk1, xk2 up to xknk. So how many number of elements here? There is a n1 elements. There is a how many number of elements? n2 elements. There is a nk elements. So here suppose arithmetic mean of this one is x1 bar. Arithmetic mean of this one is x2 bar. And similarly, arithmetic mean of this one is a xk bar. Then their composite mean is a what? Their composite mean is a x bar equal what? x1 n1 x1 bar plus n2 x2 bar up to nk xk bar divided by what? Divided by n1 plus n2 plus n3 up to what? nk. So this one is the third property. How we prove this one? Proof is very simple. So how we write this one? n1 x1 bar, n2 x2 bar. If you find the composite mean of this one by the definition of a arithmetic mean. So what is the x bar? X bar equal sum of this one means x11 plus x12 plus x13 up to x1 and 1. This one is the first series plus second series x21 plus x22 up to x2 and 2, and last one is a xk1 plus xk2 up to xnk. Nk, here this one is a x2 and xknk. So this one, and divided by what? Total number of observation. Total number of observation is what? n1 plus n2 plus n3 up to what? nk. Now, what is the value of x1 bar? x1 bar equal what? x1 bar equal x11 plus x12 up to x1 and 1 divided by what? n1. So what is the value for this one? This implies that x11 plus x12 up to x1 and 1 equal what? n1 x1 bar. n1 x1 bar. In a similar manner, what is the value for second series? The value for this one is what? n1 x1 bar. The value for this one is what? n2 x2 bar. And value for this one is what? nk xk bar. nk xk bar. So we by the definition of a mean, nothing is in this proof there is nothing else, means nothing as a complication, means here we write what? X bar equal what? X bar equal n1 x1 bar plus n2 x2 bar up to nk xk bar divided by what? n1 plus n2 up to what? nk. So this is the proof. Now we solve some numerical example based on a arithmetic mean. So now we solve one